Wait, actually worked. Alrighty.
Cool.
Welcome to our group video. Clark's going to start us off with problems 1 and 2. This is for lesson 7.
Okay, so question 1 talks about the genome of different viruses. It gives us some information, lets us know some of the contents of A, C, G, T, or U, and tells us if they're resistant to exonucleases or endonucleases, or if they're sensitive to them. So you use that information. If it's got the U, it's RNA. If it doesn't, then it's DNA. If it's resistant to exonucleases, then you know it's circular. If not, then it's linear. And if the numbers corresponding to the letters line up pretty closely with their complementary one, then you know that it's double-stranded. If not, then it's single-stranded. So for 1, these are our answers. So for the first one on it, we got that it's RNA, it's circular, and it's double-stranded. On the second one on it, we got RNA linear and single-stranded. On the third one, we got DNA linear and double-stranded. And on the fourth one, we got DNA circular and single-stranded. And then question 2 is the fill in the blank. So for the first one, so we'll show our answers real quick. Whoa, just kidding. These are our answers. They're probably going to be super blurry, so we'll read them real quick. So for the first one, topoisomerase is composed of 4 protein subunits, while nucleosomes contain the 146 to 147. For B, the DNA double helix is 2 nanometers wide, and the base pairs are separated by 0.34 nanometers. On C, overwinding induces positive supercoiling. On D, the origin of replication in E. coli is called ORIC, capital O, then RI, and then capital C. On E, the first one was labeled with sulfur, and the other one was labeled with phosphorus. And then on the last one, uridine has ribose, and deoxythymidine has deoxyribose. And that's 1 and 2.
Nice. So number 3, I'm just doing a screen share. You can see what our works that we did. Number 3, it gives you this chromosome. It asks you, well, it's 2 chromosomes that have been kind of linked together, fused. We've got 150 million base pairs total, and it asks how long this portion is going to be. So you times that by 0.34 nanometers, and that gives us 0.05338-ish, meters long. B, how many nucleosomes are found in the translocation chromosome? So in order to find the nucleosomes, you just take the base pairs and you divide it by 196 or 197. We just did 196, and that'll give you, I think it's about 80,000 nucleosomes. If you want to know how many H2A histones are going to be in there, then you have to take that nucleosome number and multiply it by 2, because there's 2 H2A, 2 histones per nucleosome. And so that's our work for C. For D, it asks for how many radical loop domains there are. I put a note that radical loops are 25,000 to 200,000 base pairs long. And so if we just do the simple math on that one, it's 6,280 to 785 radical domains. Quite the range there. For number 4, if the chromosome is stretched out linearly, how long would it be in micrometers? We got 4,410,000, and we multiplied it by the 0.34 times 10 to the negative 6 this time, because we're looking for micrometers. We got 1.4994. For B, it's asking that's the length of a circular chromosome. And so for B, it asks what the diameter is. So A is essentially the circumference. For B, all we had to do was divide it by pi, and we get 0.477 micrometers in diameter. For C, it asks if one of these loops or one of these loop domains was stretched out linearly, how long would it be? And so essentially you just take those 50,000 base pairs, just like we did in A, times it by 0.34 times 10 to the negative 6, and it'll give you 0.017 micrometers in length if it was stretched out linearly. Histones for that original chromosome is going to be the 4,410,000 divided by 196, and then multiply it by 8 because there's 8 histones per nucleosome because there's 180,000 histones in the entire chromosome. For 5, it was just looking at all of these. Those are the answers we got. We got A, E, and F for the nucleosides. For the nucleotides, we got B, C, and D. Ribose, we got C, E, F. Deoxyribose, we got A, B, D. And pyrimidines, we got C, D, and E, and F. So that is our group presentation. Thanks for watching.
Sweet. Oh no, you froze. Oh.
Great.